So if we look at class example lesson number 4 is analyzing puzzles and games. So Chris is a computer programmer and he's designing a digital arcade app for his iPad. The game's going to have 10 levels of difficulty, the first level being the easiest. At the first level, the object of the game is to drop the ball so it lands at a predetermined exit marked by one of the letters. So this is an illustration. So it says, determine how many ways there are to get to each black dot. So how can I hit this black dot?
Straight down.
Straight down. There's only one way that I could get to that black dot. How many ways do I have to get to this black dot? One. I either go this way, and then one to get that way. There's no other way that I can do that because the ball keeps going down. It's not going to go back up. How many ways to get to this black dot? One. Go straight down. How many to get to this black dot? How many to get to this one? Two. Because it could go this way, or it could go that way. How many ways to get to this dot?
3.
And did you actually draw it out? There was 1, 2, 3 like that.
I just went 2 plus 1.
Went 2 plus 1. Discovered a pattern. Okay? So when you discovered the pattern, was that deductive reasoning or inductive reasoning?
Inductive.
Inductive, because I'm using actual numbers. I'm using results. So now let's fill out the chart so I can figure out the number of ways to get to each of those letters. So how many ways to get to this point?
1.
So how many ways to get to A? There's only one way. The ball has to come straight this way. How many ways to get to G? 1. The same thing. It has to go along the outside. So if you're playing a Plinko game, do you want to actually pick the 2 outside ones? Probably not, because it's not going to have as many chances of it getting to those outside ones. How many ways to get to this point?
4.
This point. So to get to B, there's 5 ways. What about this point? Because I take the 2 and the 1. What about this point?
10.
So then, is it 10 ways or no? Sorry, I've got one. How many ways to get to B? 6. And how many ways to get to C? So then I've got, this point would be,
4.
this would be,
10.
and D would be 20. What would E be? Because this would be 5, and F would be 6. Good. So, what do we have here? Like we did this back in, it says if you go to question number 2 on page 68 in lesson 1. It's what we call Pascal's triangle. And Pascal's triangle is the outside edges were always equal to 1, and then everything inside I get from adding the top 2 each time. So did I use deductive or inductive? I used inductive reasoning because I used number examples. And how does your explanation of the pattern compare to that of question number 2? They are both Pascal's triangle. Okay, how many of you started playing the game on the next page? Because that's what you're going to do. I'm going to send you back into the other room to work on this. NAM is a game of strategy played with 2 players. 2 players take turns removing blocks or objects from separate piles. On each turn, a player must remove at least 1 object or from only 1 pile. Players may remove as many objects as they wish, so long as all the objects come from the same pile on that turn. The game may be played in 2 ways. The player who takes the last object loses, or the player who takes the last object wins. So you guys have to decide that out. So Nguyen and Henry play the simplest version of NIM to see if a winning strategy can be discovered. They set up one pile of pennies, and each player must remove 1 or 2 pennies only from the pile, alternating turns. The player to remove the last penny is the winner. So Nguyen is player 1 and Henry's player 2. So when I send you guys back into the room, when you guys are working on this, somebody's going to be player 1, somebody's going to be player 2. If you have a group of 3, somebody then does the observation. So you begin with 1 penny in the pile and start the game over by adding another penny each time until you get 6 pennies. Play the game several times because what you're trying to do is there a way that I can guarantee, if I'm player 1, is there a way I could guarantee winning no matter what? Just based on my strategy, how I manipulate the game. So the player to remove the last penny is the winner. So if I have 1 penny, and I'm player number 1, and I remove that 1 penny, I'm going to win. And you can 1 or 2 pennies. So now if I put 2 pennies on the pile, and I'm player number 1, I can take 1 penny or I can take 2. So guess who's going to win? I am, because I can take 2 pennies. And then 3, 4, 5, and 6. So I'm sending you back into the other room. You can use the counter chips or you can use the pattern blocks because they're a bit thicker. Just choose something that will allow you to stack them so that you can stack 1, 2, 3, 4, 5, 6. That's what you're going to finish up with today.